Okay, so in this video, I'll be going over indices and surds for the Cambridge IGCSE Additional Maths course from 2020 onwards. So let's start off with some basic definitions. So a surd is a number that can't be simplified to remove a square root or a cube root or etc. An index is number which is raised to a power, and radical number is number written with a radical sign, aka one of these. So these are some really basic properties of surds, which you can read over, but we don't really have to go into them right now. So I'm going to start off with some indices. So these are some basic rules of indices. As you can see, when we times two numbers together, like a to the power of m times a to the power of n, we're actually going to add the powers here and keep the base the same. Similar thing when we have something that we're dividing with the same base with two different powers, we're just going to minus the power on the bottom from the power on the top and keep the base the same. However, when something is in brackets, for example, we have the a to the power of m inside brackets here being to the power of n, we're going to times the powers together. Similarly, when there's ab inside brackets to the power of n, each number in these brackets is going to be to the power of n. Similar to this one, when we have a divided by b inside of brackets to the power of n, this can be written as a to the power of n over b to the power of n. Anything to the power of 0 is going to equal 1. And when a or any number is to the power of negative something, it's going to be 1 over your original number, such as a, to the power of what was negative before. We have some examples. For example, I'm going to start with this one right here, which is open bracket minus 3a squared, close bracket to the power of 4. So using some of the rules we have in this box over here, we're going to solve this. So as we can see from here, we can times each item in the bracket to the power of what's outside the bracket. For example, we're going to start with this minus 3a, and we're going to put this to the power of minus 4 first. And then we're going to multiply this by the a squared to the power of 4. When we times this out, we can see that it's minus 3 to the power of 4, and because we have a negative number inside the brackets and it's to the power of an even number, we know this is going to become positive, and 3 to the power of 4 is 81. And then coming over here, because there's a bracket, we are not going to add the indices. We're not going to add the indices. Instead, we're going to times them. So it would be 2 times 4, which gives us 8. So then we end up to the power of 8. A bit harder this time, we're going to work on this one, which is open bracket minus, and then we have a fraction, 2a to the power of 2, divided by b, close bracket, everything in that to the power of 3. So we're going to use the same kind of method that we used for this one. We're going to individually times each thing within this bigger bracket and put it to the power of 3. So the first thing we're going to take is this minus 2 just here, and we're going to put that to the power of 3. And then similarly, we're going to do the same thing with this a squared to the power of 3. And then the same thing with the b on the bottom, again, to the power of 3. And then we can just kind of times this out, so we're going to end up with minus 2 to the power of 3 times a to the power of 6 divided by b to the power of 3. And then, as you know, minus 2 to the power of 3 is going to be minus 8. And then this all just comes together to be minus 8a to the power of 6 divided by b to the power of 3. And then something a bit different with this one. We have some minus powers over here, which we're going to use as the last rule in this little box over here to try and get an answer for. So the first thing we're going to take on the top is this a to the power of minus 3. And we know from here that a to the power of minus n is going to end up to be 1 over a to the power of n. So we're going to do the same thing. So a to the power of minus 3 becomes 1 over a to the power of 3. And we can do the same thing to this c to the power of minus 1 on the bottom here. We get 1 over c to the power of minus 1, which is actually just going to come out to be c to the power 1, which is just c. So we can actually put these back into this now that we know what they are, without the minuses. And we know that the c, instead of being 1 over something, it's just going to be by itself. So we can move this from the bottom here to the top. And the a is going to now has 1 over it. So this can be put on the bottom, and that's how we end up with b squared times c over a to the power 3. Last example on these rules is going to be this one right here. And this one says write 1 over 2 to the power 1 minus n in non-fractional form. So it wants us to take it out the fraction. So we're going to use kind of the reverse of this one right here. So it says a to the power of negative n is equal to 1 over a to the power of n. And here we have 1 over something. So we're going to use the reverse, and instead we're going to use that 2 on the bottom, and we're going to put 2 to the power of minus, and then what was the exponent on the 2 on the original form it was in. And then we end up with 2 to the power of negative, open bracket, 1 minus n, close bracket. And then we can just times this bracket out. So minus times the 1 is going to make it minus 1, and a minus times the minus makes it a plus. So we end up with 2 to the power of minus 1 plus n. And then we can just rearrange these two, the minus 1 and the n, to make it look a bit neater. And then we get 2 to the power of n minus 1. Exponents can also be used in factorization and expansion. And just here in this little box here, we have some rules on how to do that. It's basically just the smiley face method. You know, you times the a by the c and the d in the other bracket, and the same with the b afterwards. So all these other rules, which you already know from GCSE, so I won't go over in detail. So the first example we're going to use here is factorize 2 to the power of n plus 3 plus 2 to the power of n. So we basically want to isolate this 2 to the power of n so that we can put it together with this, so they are the same. So to get this, we can see that 2 to the power of n plus 3 is the same as 2 to the power n and 2 to the power of 3. And then because we have the same thing on both sides, 2 to the power of n and 2 to the power n over here, we can use that to factorize. So when we divide both of these by 2 to the power of n to get what's inside the bracket, we can see what's left here is 2 to the power of 3, and what's left here is just 1. We know 2 to the power of 3 is just 8, and when we add 8 to 1, we get 9. And then we just times it out, so it becomes 2 to the power of n times 9. And then a second example over here, 3 to the power of n plus 6 to the power of n, all divided by 3 to the power of n. So we're going to start trying to get 3 to the power n from over here so it matches the other two. And to do this, we're going to look at, well, what two factors make 6. And from that, we can pull 2 and 3 to give us 1, 3n so that we can factorize. So then it becomes 3 to the power n plus 2 to the power n times the 3 to the power n all over 3 to the power of n. And then we can factorize, so outside of brackets we get 3 to the power n. Open brackets, we get a 1 from dividing this by 3 to the power n. And then we get 2 to the power n on this side of the bracket from dividing this by 3 to the power n. And then this is again all over 3 to the power n. But because we have the same thing top and bottom, we can now cancel them out so that we are left with 1 plus 2 to the power n over 1. And anything over 1 is just itself, so we are left with 1 plus 2 to the power of n. So the next thing to mention are graphs for exponentials. So if we have the general form of y equals a b to the power of x minus c plus d, we can tell which one controls what's happening on the graph. So b here is going to control how steeply the graph increases or decreases. Our C over here is going to control a horizontal translation, aka if it's moving left or right. Our D here is going to control vertical translations, i.e. if it's going up or down. And then the equation of the horizontal asymptote is y equals D. So then we have some general, like, what's happening when certain numbers are between certain things. So I'm going to go straight into an example here. I've got the same box as before just so you can see what's happening. So we have sketched the graph of y equals 2 to the power of minus x minus 3. And hence they want us to state the domain and range of the function. From our rules over here that the horizontal asymptote is y equals d, and here our d is basically -3, so we know that's our horizontal asymptote. We also want to find out some points on our graph so that we can plot it and sketch it. So we're gonna first of all take when x equals 0, and we're just gonna put 0 in the places where the x's are, and this just comes out as -2. So we can plot this point right here. When x is 0, y is -2. This also gives us the y-intercept. And then we can plot some more points. So when x is 2, we just put 2 into where the x's are and try and get an answer, which comes out as -2 times 3/4, which gives us this point right here. And then when x is -2, we do the same thing as we've done here and here, and that comes out with 1, which gives us this point, and then that gives us something we can sketch right here. And then, as you can see from the graph, the domain left from right is going to be infinite. As long as x is a real number, the graph is going to be able to go there. And we can see here that the graph tends towards this line right here, but is never gonna reach it. So that gives us that the range has to be bigger than -3. The thing we need to know is that as long as base numbers are the same, you can equate indices. So example, a to the power of x equals a to the power of k, then x is going to equal k. So two quick examples here. We're going to solve for x. For 2 to the power of x equals 16. You'll be able to recognize 16 is actually just 2 to the power of 4, and then we end up with 2 to the power of x and 2 to the power of 4, and because the base there, the number 2, is the same, we can equate the x and the 4 to get x equals 4. Second example, 3 to the power of x plus 2 equals 1 over 27. So 27 you'll recognize is 3 to the power of 3, but there's 1 over, so there's going to be a negative in the exponent, giving you 3 to the power of -3 right here. And this side is going to stay the same. But because our base here on both sides is now 3, we can equate the exponents here to get x plus 2 equals -3, and then we're just going to move this 2 to the other side to get x equal to -5.